Hi, everyone. Hope you are well. Sophia Peter here, and thank you so much for tuning in, first of all. And thank you to Product School for inviting me. I'm very honored to be here. Today, I'll talk about how you can be a top-notch PM using data science. I'll give you very practical tips, and I'll also give you some high-level context about data science, but I'm not going very deep on the technical aspects of it. The $15.7 trillion game changer. This is how much AI could contribute to the global economy in 2030, according to this study from PwC. To put this into perspective, this is more than the current GDP of China and India combined. However, even though most executives agree that AI represents an opportunity, only 18% have tried to use this technology to generate revenue, according to this survey from MIT and BCG. So I guess it's clear that more companies need to focus on this technology to create value. And hopefully with this webinar, you'll get some ideas on how to extract value from data science to your company and how you can give a great contribution as a PM. So here's the agenda for today. First, I'll talk about why should you care about data science as a product manager more in depth. Then secondly, I'll talk about when you should use data science. And thirdly, I'll also cover how can a product manager contribute to data science driven products or to a data science team. First, a little bit about myself. I'm from Lisbon, currently living here, and I'm a product manager with several years of experience in product, currently working at Farfetch, where I'm lucky enough to work with a team of brilliant data scientists and other product managers too. Our team's mission is to create innovative products that solve operational problems using data science. Before Farfetch, I worked at Unilever, then moved to London to join Bloomberg, and later worked as a PM at Enbabel, which is an AI-powered translation platform. While still in London, I quit my job to start my own startup called Misk, a mobile app with restaurant recommendations from people you trust. That was probably one of the best experiences of my life because as a founder and also as a CPO, I had a chance to own the product end to end from ideation to a real product, which implied coming up with a strategy, figuring out how to execute it, incorporating user feedback into the product, and so on. I think that was when my love for product was born. And before we move to what matters, a few disclaimers. I'm someone who has been working as a PM with a data science team. I'm not a data science myself, as you probably already figured. All the learnings I'll be sharing with you are based on my own experience. And I also might use the terms data science, AI, machine learning interchangeably. So on this webinar, I'll mainly cover what I've learned so far that has helped me succeed as a PM working with data science. And as I said at the beginning, I won't go super deep into the more technical topics. Great, so I already shared that the opportunity is big for data science, but why should you care? I thought it would be useful to first understand what is data science or what is a data science problem with two simple examples. Meet Sarah. She's a successful entrepreneur who launched an e-commerce business where she's selling clothes. She aspires to have her own physical store, but for now, she only sells online and stores all the items in a warehouse. Sarah can use one of these three boxes to ship her items. So let's say that the customer orders a pair of jeans and she's wondering which box should she use to pack the pair of jeans to send the product to the customer. Probably she will consider some characteristics such as category, size of the jeans, weight, and so on. And she quickly concludes that box 2 is the best option. Easy peasy, right? Over time, Sarah won't have to think about again which box to use for this particular item, as obviously these characteristics of the item do not really change over time. This is what we call a deterministic problem. For this pair of jeans, we'll always get the same recommended box. Now let's take a look at another situation. Sarah wants to create a great customer experience, and based on the feedback that she's getting from customers, she believes that providing customers with an estimation of when the item will arrive will improve the experience of the customers. So she now asks, how to estimate when the order will arrive to the customer? As you can imagine, there are several factors that Sarah needs to take into account as they influence the date of delivery, such as the courier, if it's a regular or express service, the warehouse location, where the customer is located, the hour of the day, and so on and so forth. And these variables do change over time. They will give Sarah different estimations or outcomes at different points in time. So this is not a deterministic problem anymore, but rather probabilistic, because the estimated delivery date won't always be the same depending on the point in time that you are. So in this case, instead of writing code with like hard-coded rules that always behave in a predictable manner, Sarah needs machine learning friends to build an algorithm that is capable of looking at thousands of historical data points of orders and use them as training data for a model. So she needs to build a data science model if she wants to get more accurate delivery dates. Now, going back to the initial question, why should you care? We already know that, again, the opportunity for data science is big, and that's because there are tons of business applications for it that can create value both for end users or for the business itself, from image recognition or forecasting where you want to predict the future, or machine translation, fraud detection, recommendation engine, and so on. You don't have to reinvent the wheel, actually. That's the good news to get started. You can look at what other companies are doing, such as Google, Facebook, Netflix, Spotify, etc. I'll actually share some interesting articles at the end for you to read with well-known use cases out there. So here is the takeaway from part 1. Some problems are solved by data science. Some others are not. And in fact, there are many problems where you can apply data science and enable innovation as a product manager. Awesome. So let's jump into the second topic of this session, which is to talk about when should you use data science. As we have seen just now, not every problem related to data is a data science problem. So how to know when to use it? A good thumb rule is if a problem can be solved in Excel, you don't need data science to handle it. So let's dig a bit further into this. On the second part, I'll share with you a framework to help you understand as a product manager if you should consider data science as a solution before starting any project. So let's take a look at the definition of a data science product first. Data science products are automated systems that learn complex patterns from historical data, and based on those patterns, make predictions on unseen data to make or recommend business decisions. By the way, this is not an official definition, but it does sound very complicated. So let's break it down. First, you can use data science if your problem is complex. Think about Airbnb with lots of house listings where each listing comes with a zip code. If you are looking to sort listings into the regions they are located in, you don't really need data science for that. The pattern is simple. Each zip code corresponds to a known region, as you can see on this image. For this, you can just use a lookup table in Excel, for example. But if you need to predict the price of a new listing, that is more complex, I suppose. The price of the house depends on how big the lot is, how many bedrooms the house has, the year it was built, the neighborhood, demands for housing in the area, mortgage rates, and so on. So it sounds like it's quite a complex problem to solve in Excel. Second point is there are patterns to learn in your data. So if you try to predict the next outcome when rolling a dice through machine learning, that won't work as there are no patterns. Each of the faces has the same probability of landing facing up. So it's entirely random. However, if you give a machine examples of pictures showing a human face, as you can see here, then it will be able to learn the pattern and detect the human's face on the following pictures. And going to the third point, there is historical data to learn from, or data is available, or you can collect it somehow. For data science to work, it needs to learn from data. So you not only need large amounts of data, but also good raw data. Meaning that, for example, if you are trying to classify emails as spam or not spam, then you need to have access to thousands of emails, with some of them classified as spam, so the machine can learn. Then this data needs to be relevant to your problem, so that unseen data follows the patterns of the training data. In other words, and making it more simpler, the algorithm can make predictions based on data it has not seen before. So let's look at another example, and going back to actually Sarah's example. In 2018, Sarah used to work with DPD, a delivery company, to ship her products to customers. Now in 2021, she expanded the business, and so she decided to partner with DHL and UPS instead. Since she's working with new delivery companies, if she has a model to predict the delivery date for an order placed today, it really won't perform very well if it's trained on data from 2018, when Sarah used to work with a different career. Yeah, and that's because basically that data is outdated. So she's better off training an algorithm with data from 2021 to learn the correct patterns and make good predictions. Additionally, it also makes sense to think about using data science if you also have a problem that is at scale. At scale means, do you have 100 orders or $1 million orders? If you have just a few orders in data science terms, then it will be very hard to make predictions. And think about also if your problem changes across time. So for example, let's say you want to predict the next US presidential election. It may seem that you only need one prediction every 4 years because the election only happens every 4 years. But in fact, you might need to make a prediction every hour or so, since that prediction has to be updated with new information over time. All right, that was maybe a lot of information, but let's wrap up the section and review the 6 points I mentioned. So if your problem is complex, if there are patterns to learn, if you have historical data or you can collect it, if you have unseen data that follows the patterns of the training data, if your problem is at scale, or if it actually changes across time, then data science has a lot of potential to be used. This list is not exhaustive probably, but it might give you a hint already on when you should use data science. And if you forget everything that I just said, just take away that this framework is important because as a PM, you should understand if it's worth investing in data science or not, i.e. if the cost-benefit equation will make sense. So that leads me to my next topic, which is how can a product manager contribute to a data science team or product? So guess what's my first advice to you? Clearly define the problem and the why. Start with customers, of course. This is a key component of traditional product management, but super important too if you work with data science products. The potential of data science it can be quite fascinating, but your goal as a PM is still very much about solving customers' problems. So as a PM, you really need to remember to remain customer-centric in the face of data science and ask these questions. Who is this for? What is the underlying pain point, unmet need or opportunity? Why should we do it? So yes, this is probably no news for you, but it's essential for data science PMs to state the reason why you and your team should invest time on it. Then the second point is that you should measure the value added to the business or customer. In other words, measure the size of the opportunity and measure the impact that the product will have in case it solves the problem. This also probably applies to any product that you will build, but even more so to data science products because the stakes are higher. It can be quite expensive to build a data science product, as you need to invest more time in research upfront. And there is also higher uncertainty of success in comparison to traditional software products. So measure the impact you can have always beforehand. And actually my next point is related to this, which is try to help your team find high impact problems. And I believe there are no silver bullets to find high impact data science problems to work on, quite frankly. But here are a few useful questions you can ask. Where can you automate time-consuming manual processes? Where is the friction, or where is there friction in your product? What are other companies doing out there? Read the internet, read online. There are many examples of companies using data science already. You should also always try to run a feasibility check early on. One of your missions as a PM is to prioritize projects to work on. So you should not only find high impact problems, but also assess the potential costs and challenges associated with them. So think about, what do you know today? In these 4 different areas, it's my advice. In terms of data availability, ask, do we have the data needed? If not, can we acquire it? From a functionality requirement perspective, what are the minimum features we need? What's the scale and performance levels we need to solve a given problem? Then on the problem difficulty side of things, you can think about, can a human do it? Have other companies tackled this problem before with data science? And finally, you can also run a confidence check. So can you predict if customers will want it? Do you have data to support your hypothesis today? This feasibility check will for sure help you set your project for success. All right, my next tip should be also no news for you if you already work in the product area, but I think it's still worth pointing it out. Start small and really pay attention to the minimum viable product. Before you have data and experiments that tell you that you should go big. So with data science, we'll see, as we see later, you have always this research stage where you will understand if you should, after that stage, you will understand if you should invest more in the project or not. And by minimum, I mean, what's the simplest model you can build before making a huge investment on more complicated models, as I just said? What are the minimum features needed? You can have this discussion with your team. For sure, your data science team will help you on this. And viable, what will be what will be viable to build in a reasonable amount of time? What can you productize now, and what will be viable in an uncertain time frame? Then the sixth point is for you also to try to identify risks upfront. Again, together with your team and stakeholders, of course. And I guess there are many different types of risks that you should consider, as you can see here, from privacy to security, fairness, and so on. But today, what I wanted to highlight is how data science can be unpredictable. And as a product manager, your role is to clearly involve your stakeholders and give them visibility on the different stages that a data science project can take. For example, they should be aware that before making any predictions, the team needs some time to research and clean the data, and that can take a lot of time. It can also happen that after exploration or research, you conclude that you cannot really solve the problem and that machine learning is not the optimal solution. And even after the research stage, it's not certain that these predictions will be good enough, as I said. Okay, seventh point is probably one of the most important advices that I have for you today: making data science products impactful. This should be your bread and butter, because ultimately the predictions from the model should empower your stakeholders to make informed decisions and take action. So let me give you a practical example. Let's say your team builds a model that predicts returns both at cart and product level. As a PM, you can help your team think about use cases where this model can add value and reduce returns across the customer journey. So for example, I'll give you a few examples of actions that you could take with this model. You could show personalized delivery charges to the customer, as on the first two images on the left side. And if you see on the second image, all items are similar, which can be a reason for high return probability, hence a higher delivery charge. You can also make products, for example, non-returnable for products as on the third image. And this is for products that have a higher probability of return. And instead, you could give customers credit for them to spend on your website. And there are other ways to make the model useful and reduce returns, such as you can, for example, advertise the negative environmental impact of making a return. You can refund customers in credits so they buy with you again. Or you can even take a more extreme action, which is to block orders at checkout that have a really high return probability. So last but not the least, you should be the advocate and connect the dots. As a PM for data science, you must advocate for more than just a product. You must also understand and promote the merits of data science adoption to help your company stay competitive, and help your colleagues understand what can data science do for the products they manage or for the business areas they work in. And as a data science PM, you should also connect the dots. You are basically the translator, because you bridge the language of data science with the language of product development and connect the dots across all teams and products involved in building a data science product, understand well the use cases for it, and involve anyone necessary in the process. So yes, it really does take a village to build a data science product, but it's a lot of fun too, I can assure you. Great, so to wrap up, here are my 8 tips on how you can be a top-notch PM while working with a data science team or product. Let's review them quickly. So first, clearly define the problem and the why. Second, measure the value added to the business or customer, the opportunity size. Third, help your team find high impact problems. Fourth, run a feasibility check. Understand what's viable and what's the minimum, which is related to the fifth point. Start small. Don't go from the get-go with very complicated models. Sixth, identify risks upfront and manage your stakeholders' expectations. 7th point is try to make data science products impactful and useful. And last, be the advocate and connect the dots. Finally, as promised, here you have 4 great articles. The first 2 are more generic and talk about product management for AI. And the last 2 talk about 2 different use cases for data science. One from Spotify with the Discover Weekly, a very well-known feature from Spotify. And the last one from Airbnb. So that's all for this webinar. Thank you so much for your time. I hope it was useful. And feel free to reach out to me on LinkedIn or on the webinar page afterwards. Bye.